Hi everyone. Yesterday we talked about simplifying expressions and solving equations, and I know the lectures go by really fast, so I wanted to take a moment and slow down and talk a little bit about distributive property and also about solving equations when you have variables on both sides. Okay, so with distributive property, let's start off with something like this. I've got 2 times the quantity of 3 plus 4. Well, if you're going to do orders of operation, you're going to simplify what's inside the parentheses first. So 3 plus 4 is 7. And then you will do your multiplication and you get 14. All right? Which gives the same answer is, let's do this a little bit different. I've still got 2 times the quantity, 3 plus 4. 2 is being multiplied by everything on the inside. So 2 is going to get multiplied with the 3. That addition sign, I'm going to go ahead and bring it on down. And then 2 is going to get multiplied with the 4. Now let's simplify both of these. Let's multiply before we add. So I have 6 plus 8, and 6 plus 8 is 14. So we get the same answer both ways. Now, if you're not dealing with any variables, it's easier just to use your orders of operation. Okay? Why do we need distributive property? Well, what if I do this to you? I remove the 3 in that expression and replace it with an x. You no longer can simplify what's on the inside of the parentheses because it's already simplified. There's nothing else you can do with it. All right? I don't know what 3 is. It could be, or I'm sorry, I don't know what x is. It could be 3 or it could be another number. But here's where distributive property comes into play. I can't use orders of operation, so I'll use distributive property. 2 times the first term in the parentheses, bring down your plus, and 2 times the last term in the parentheses. Okay? You would multiply 2 by any of the terms. I mean, if there were 3 or 4 terms in the parentheses, you'd multiply 2 by all of those terms. Now, if we simplify 2 times x, you get 2x, plus 2 times 4 is 8, and that's your simplified expression. There's nothing else you can do with it. Because there's no equal sign, you can't solve for x. That's all you can do. Okay? Let's try that with an example. I've got 20 equals 4 times the quantity 3x minus 1. Okay, when you're solving an equation, the first thing you want to do is simplify each side of your equal sign. On the left-hand side, there's nothing you can do with 20. It's simplified. On the right-hand side, yes, we're going to use distributive property to simplify this. So, I'm going to take 4, and just for the moment, I changed subtraction. We know subtraction is the same as adding the opposite in the sign. So subtracting is the same as adding a negative. So I did that just for the moment. I don't normally do that, but I want you to see all the steps. So now I'm going to take 4 times my first term, and then I'm going to add it to 4 times the second term. That gives me 20 equals 4 times 3x is 12x. I brought down the plus. 4 times the second term, that's a 4 times negative 1, which is negative 4. Now, adding a negative is the same as subtracting. So I'm going to put it back like that. Usually what I do, let me show you what I do. Usually when I use distributive property, I will take 4 times this first term, which gives us the 12x. Subtracting is the same as adding the opposite. I usually take that subtraction and assign it to that number and call it negative 1. So positive 4 multiplied by negative 1 gives you negative 4, which is that right there. And I just write it negative 4, same as subtract 4. All right? Now we're not done. We're trying to solve for x. We've simplified both of the sides. Now we've got to start peeling away everything that's preventing x from being by itself. And I don't know what 12 times x is, but the first thing that's easy to get rid of is the subtraction by 4. How do you get rid of subtraction by 4? You're going to add 4. And what you do to one side, you have to do to the other. And when I mean side, I mean each side of the equal sign. I see a lot of people that will do this. Okay, I'm adding 4 here, so I have to add 4 here. But this is incorrect, because what you do to one side, you have to do to the other. Don't add 4 twice on both sides. You'll get the wrong answer. And you'll know you have the wrong answer when you do your double check. Don't forget your double check. All right, 20 plus 4 is 24. Over here, negative 4 plus 4 is a 0 pair. All right, what's preventing x from being by itself? Multiplication by 12. How do you undo multiplication by 12? Yeah, you divide both sides by 12. I left out a 1 right there. Divide both sides by 12. Divide this by 12. Divide this side by 12, and you get x equals what? Yeah, we get x equals 2. I have to fix my PowerPoint. Now, double check. Replace x with 2. 3 times 2 is 6. 6 subtract 1 is 5. And 4 times 5 is 20. Check. Okay? Always double check. All right. One more thing I want to talk about is solving equations with variables on both sides. I have 5x equals 2x plus 3, and when I talk about sides, I'm talking about the equal sign dividing up your left side and your right side. Okay? And I'm going to give you a visual with this one. Okay, I've divided up my sides. Over here, I've got 5 x's on the left-hand side. On the right-hand side, I have 2 x's plus 3 singles. So this is 5x equals 2x plus 3. Okay? What you do to one side, you must do to the other. I'm going to subtract 2 x's from here, which on the right-hand side, if I remove 2 x's from the right-hand side, I have to remove 2 x's from the left-hand side. So this is what it looks like, and here's what I've done. I've subtracted 2x from both sides. I'm left with 3x over here equals 3 singles over here, and I'm going to group those together. Each x on this side is worth how much? Yeah, each x is worth 1. And what I actually did was I divided both sides by 3. Let me back that up. I want to get x by itself. It's being multiplied by 3. How do you undo multiplication by 3? You divide by 3. And what you do to one side, you must do to the other. Those cancel each other out. You're left with x equals 1. All right? Now, here's the question. People will ask me, what if you subtract 5x from both sides? It can be done. On this side over here, you don't have 5x's to remove. So if you go ahead with the process of removing 5x's from both sides, this side gives you negative 3. I'll show you that in a minute mathematically. You'll get negative 3x on this side, and it is best not to introduce a negative sign if at all possible, because it's so easy to drop a negative sign. All right, let me show you mathematically what it looks like if you were to do it. I'll show you that we still get x equals 3. All right, let me drag this over. And I'm going to fatten up my pen. I like a little bit fatter pen. Okay, and let me show you, let me put back in this so you can see the sides. If you were to subtract 5x from both sides, I'll do that. What you do to one side, you got to jump across the line and do to the other. Okay, over here, what's 5x take away 5x? There's actually, it's nothing. Yeah, 5x take away 5x is nothing, but what number represents nothing? Yeah, that's 0 equals, here I've got 2x minus 5x, which gives me negative 3x plus 3. There's a couple different ways you could approach this now. If I'm trying to solve for x, Let's get rid of addition by 3. Never do the division first. Let's get rid of this guy that's hanging on over here. Let's subtract 3 from both sides. What you do to one side, you have to do to the other. So I've got negative 3 equals negative 3x. I want to get x by itself. It's being multiplied by negative 3. How do you undo division by, or multiplication by negative 3? Yeah, you divide by negative 3. And what you do to one side, you must do to the other. So here we get x equals negative 3 divided by negative 3 is positive 1. I told you we'd get the same answer, but if you go this route, it's so super easy to drop. Look at all these negative signs we're dealing with. It's so easy to miss one of those, drop it out, and get the wrong answer. All right? So it really is much safer to work your equation and keep your variable positive. Okay? That's it.